Okay, problem 3. Find the equation of the following planes. So, part A, the plane contains a point 6, 6, 3, 2, and is perpendicular to the vector. And its normal vector is negative 2, 1, 5. Okay, so how do you get the equation describing this plane? So the trick is, okay, first you must need two things, right? First thing is you need a point on the plane. Okay, second thing, you need a vector that is perpendicular to the plane. Okay, so now you can assume you can pick another random point on the plane. You call it x, y, z. Okay, and you connect these 2 points on the plane. You connect these 2 dots on the plane, you get a random vector on the plane. Okay, and we know that this random vector, this blue vector, is perpendicular to this black vector. Okay, so when 2 vectors, they are perpendicular if and only if their dot product is 0, right? So now we have our 2 vectors. The first vector is a random vector on the plane, which you use the end point minus the start point. Okay, this is a blue vector. Dot product, the normal vector, this is a vector that is perpendicular to the plane. Okay, so it's perpendicular to the plane, so it's perpendicular to any vector on the plane. Their dot product must be 0. Okay. Then you can solve this, and you can get the result you want. Okay, plus y minus 3 times 1 plus z minus 2 times 5 is equal to 0. So it's negative 2x plus 12 plus y minus 3 plus 5z minus 10 is equal to 0. So it's minus 2x plus y plus 5z is equal to 1. Okay. So this is part A. Part B. Okay, part B. The plane contains a point. Okay, the plane contains a point 3, 5, negative 1. Okay, and it also contains a line. Okay, and this line is, right, it's given, you are given the parametric equation, but you can also write down its in its expression in this way. It's 4, negative 1, 0 plus t times negative 1, 2, and negative 3. Okay, so now it's harder than part A because now you don't have the normal vector that is perpendicular to the plane, right? But you need that to get the plane's equation. So you need to first figure out what is the normal vector perpendicular to the plane. Okay, what is this? Okay, so here we need to be creative. We need to use the cross product, right? Because the cross product between u and v is perpendicular to u and perpendicular to v. Okay, so first we need to find 2 vectors on the plane and do the cross product to get n. Okay, to do that, we can use the direction vector of the line, right? Because we already know this vector is on the plane. So what's that vector? It is just t times this vector, right? So we can use this as our direction vector. Negative 2, negative 1, 2, negative 3. This is on the plane, right? This vector is on the plane. Okay, and we need another vector, and it cannot be the same vector. Right? If 2 vectors are the same, it doesn't work. So we need a different vector. Okay, don't forget about, we also know there's a point on the plane, right? So we know there's a point on the plane. What about another point on the plane? We can just let t to be 0. Okay, then this 4, -1, 0 is also a point on the plane. So this 4, -1, 0 is also a point on the plane. So, okay, just now we get u. Okay, this is my u, and now I get v. Right, this is my v. We can just use 3, 5, -1 minus 4, -1, 0. Okay, it will be -1, 6, -1. All right, so now we have our u and v. We just need to do the cross product. U cross v. Okay, here I think I can skip some of the steps. You can just follow the formula of u cross v. Yeah, it's just -1 to -3 cross -1, 6, -1. Okay, maybe let's do it one more time here, because so the first is you temporarily remove the first component. It's going to be the determinant of 2, -3, 6, -1. Okay, and minus the second component is you temporarily remove the second component. So it's -1, -3, -1, -1. And then you temporarily remove the last component. It's -1, 2, -1, 6. Okay. Then you do the determinant. So it's the product of these two numbers minus the product of these two numbers. Okay, so it's -2 minus -18. So I can write down there. It's a product of these two numbers minus the product of these two numbers. Okay, so it's -2 minus -18. It is 16. Right. The second one is the product of these two numbers, which is 1, minus the product of these two numbers, which is 3. Right, so it's -2. With the extra negative sign, it's 2 here. And here it's a product of these two numbers minus the product of these two numbers. Okay, so it's -6 minus -2, so it's -4. Okay, so this is u cross v. This is a vector that is perpendicular to the plane. Okay, so now we can do the same trick as in part 1, right? Now we can just pick a random vector, we can pick a random point on the plane and then connect it to 3, 5, -1. Then we have a random vector on the plane. Okay, this x minus 3, y minus 5, z plus 1. This is a random vector on the plane. And this random vector on the plane is perpendicular. Okay, is perpendicular to n. So its dot product with n is 0. Okay, its dot product with n is 0. So 16 times x minus 3 plus 2 times y minus 5 plus -2, -4 times z plus 1 is equal to 0. Okay, so it's 16x minus 48 plus 2y minus 10 minus 4z minus 4 is 0. Okay, just summarize it, do the simplification. Okay. It's 8x plus y minus 2z is equal to 31.